Practice number 1. At the beginning of an experiment, the average number of wolves in a pack was counted at time equals 0. The number of wolves in the pack T years after the initial count was modeled by the function W equals 4 times 1.5 raised to the T power. What is the average rate of change in the number of wolves in the pack between years 1 and 5? Here's a good chance for you to practice, so pause the video, see if you can calculate the average rate of change, and then when you have your answer, resume watching the video to compare your answer with what you see on the screen. And welcome back. Okay, let's see how you did. So we do know that the time is going to be 1 and 5 because we're looking for the average rate of change in the number of wolves in the pack in years 1 and 5. So T, our initial value, will be 1. So we plug this into our equation. 4 times 1.5 raised to the first power gives us 6 wolves. When T is equal to 5, I replace T with 5, and I take 4 times 1.5 raised to the fifth power, gives us 30 wolves. Now it's time to calculate the average rate of change during those years. The average rate of change is related to slope. Okay, so if we were doing this on a graph, we'd be finding the slope of a line. Using equations and data, it would be calculating the slope or average rate of change. So we start off with y2 minus y1 over x2 minus x1. But to make this specific to our pertinent to our particular situation, I'm going to replace y with w for the number of wolves, and x I'll replace with t for time. Making the appropriate substitutions and doing the arithmetic, we find out that the average rate of change is 6. So, in summary, the pack increased at an average rate of 6 wolves per year.